linear equations and its graphs. Whenever we talk about linear equations, we're talking about a equation that's to the first degree, which is called first degree, meaning that whatever our variable is, if it's x, y, z, w, whatever it may be, it's to the first power. Of course, we don't write it on there because we know y to the first is written as just y, right? So a linear equation literally means that my variable is to the first power. And as you see here, we have an example of ax plus b is equal to 0. This is a linear equation where the variable is my x, a and b are my constants, meaning it's just any number, negative or positive, it's a number. A is my coefficient on x, okay? And in order to solve for x, we need a to be a positive 1. However, in order for this to be a true linear equation, a cannot equal 0. If that is so, then that's 0 times x, which is 0. Then there's no variable, there is no linear equation here. Theorem 1 tells us the process to solve for the variable in a linear equation. So let's just do that without having to read all this. I'll go through it in steps. So let's do example 1. Example 1 shows that we have a variable of x to the first power. So that means these are all like terms. And since they're all to the first power, we know it's linear, right? Also, whenever we go add, subtract, multiply, divide, whatever it is, we need to clean up each side before we do it. And then we need to make sure our variable, in this case is x, is on one side of the equal sign and all our constants on the other. And then we got to make sure our x has a positive 1 coefficient, and then we know what x is. And then we can plug it back into the original to solve. So that was a lot of information I gave you, so let's just do it. What I'm going to do is I'm going to look at the first side of this equal sign first, and I see that I got 8x minus, well, this 3 is going to get distributed to everything inside the parentheses, but it's not just 3. If you notice, that negative goes with the 3. So I got negative 3 times positive x is a negative 3x. And negative 3 times a negative 4, which is a positive 12, because negative times negative, right, is positive. And then I have my equal. All right, on this other side, I have a positive 3 being distributed. So 3 times x, and they're both positive, so it's positive. Positive 3 times negative 4 is a negative 12, plus that 6. All right, so I got the parentheses taken care of. So before I start moving to each side of the equal sign, what I need to do is look and see, do I have any like terms? I do. The 8x minus 3x is like terms. Let's put them together. So it's like saying I have $8, I spent 3, so now I'm down to 5. Let's bring down the plus 12. This other side, I have 3x, and it's the only variable term on this side. My constants, however, are like terms. So I have negative 12 plus 6, so I'm in the whole $12. I deposit 6, so I'm only in the whole 6. All right. Now, what I want to do, that I got both sides cleaned up, I want to move all my variable terms to one side of the parenthesis and all my constants to the other. Since I always read my equation left to right, I want to move my variable term to the left. So 3x is positive, so I'm going to subtract it. And when I do to one side, we have to do to the other. This goes to 0. That's what we wanted. Bring down the negative 6, bring down the equal, bring down the plus 12. 5x minus 3x, I had $5, spent 3, now I got $2. All right, now I need my 12, which is a positive constant, right? It's on this side. I need it to go to 0, so I'm going to subtract it. What I do to one side, of course, we got to do to the other. Writing was just a little bad there. Let's clean that 2 up. That looks terrible. All right. So now that went to 0. Good. Bring down the 2x is equal. Now I'm in the whole $6 and I spend 12. I am in the whole 18. All right. Now I got to look at my variable term. It is by itself. We agree. It's isolated from the constant. However, the coefficient on it's got to be a positive 1 and it's a positive 2. So I'm going to divide by 2, right? 2 goes into 2 one time, leaves me with x, and that's what I wanted. What you do to one side of the equal sign, we're going to do to the other. 2 goes into negative 18, negative 9 times. Now this is my answer, but we want to check to make sure it's true. So I'm going to come over here and check. And how am I going to check? Let me split my screen into, whoops, got a little curvy on there. I'm going to take my original, and everywhere I see X, I'm going to put that negative 9. So we want to see if one side of the equation equals the other. I didn't give myself enough room, so give me a second. Let me just clean this up a little bit, scoot it over more. Let's see if I can't give myself more room. Now, I got 8, and then I'm going to put the parentheses where I see the X, give myself some space. Space. All right. Now, if it's true, both sides of the equal signs will be equal. Let's plug in the negative 9. All right. Now let's do this one. All right. So now that positive 8 times negative 9 is a negative 72. I got a negative 3 times, oh, let's clean that up before I distribute that negative 3 to inside there, right? Because we know the value of negative 9 and negative 4. So I'm in the whole $9. I spend $4. I'm in the whole 13. Let's come over here and clean this up. Well, negative 9 minus 4 is negative 13. All right. Next, I'm going to distribute that 3 to that negative 13. So I got negative 3 times negative 13. We know it's a positive, right? And then 3 times 13 is 39. Well, this 3 here is positive, and this one's 13 is a negative, so I got a negative 39. Let's bring down that negative 72. Now, I got, so say that I got $39 in the bank, but I spent 72. It says that I'm in the hole 33. We want to know, does that equal what's on this other side? Well, let's say that you had $6 in the bank and you spent 39. I'm in negative 33. That is true, right? That's true because negative 33 does equal negative 33. So I'm going to say true. That's my answer, negative 9. All right, let's go to our next example. Again, we have a linear equation here. It's a little complex, but we do have one. And as you notice, our X is involved in a fraction. In order to solve for X, we have to get it out of that fraction. So what I'm going to do is just set this up where I multiply by whatever it takes to undo it. And let's talk about that. All right. To undo this fraction, I would need to multiply by a number that 2 would go into and 3 would go into. Well, 2's prime and 3's prime. If I multiply these two together, I get 6. That's the number I'm wanting to use. So let's come over here. I was going to change this color up. There it goes. So I'm going to say 6 over 1. 6 over 1. But remember what I did to this side, I have to do to this side. Well, I don't have to put 6 over 1 for here because it's going to be just what, 5 over 1. That's not simplest form, but I only did that for myself so I can say, oh, it did reduce. See that? It did reduce. 2 goes in itself once, goes into 6 3 times. 3 goes in itself once, goes into 6 2 times. Now I got 3, and I'm going to have it multiplied by x plus 2 minus 2 times that x equals 6 times 5, which is 30. And we don't need to put ones underneath these because that's not simplest form. That one's there is just to let you know that we're undoing the fraction. Now I'm going to distribute that 3 to everything in the parentheses. So 3 times x plus 3 times 2, and they're both positive. And before I get x isolated by itself, I see that I can combine that 3x minus 2x. So that says I have $3, I spent 2, so I'm down to 1, and it's positive, right? Now let's look at that 6. That 6 is a constant and it's positive, so let's subtract it. If I subtract it here, it goes to 0, but what I do to one side, I must do to the other. So 30 minus 6 is 24. That is my answer. And again, we can check our work, right? We check our work, we can take our original here And I'm just gonna write everything down, leaving a little bit of space for where the X goes. And we're gonna make sure one side equals the other. And what is X here? It's 24. All right, so now I got 24 plus 2 is 26 divided by 2 minus, well, 3 goes into 24 8 times. If you can reduce, I would. I see that 26 divided by 2 is 13. It reduces. 13 minus 8 is 5. Well, this is true. 5 is equal to 5, so true. 24 is my answer. All right, let's talk about finding a variable or some kind of term in a formula that's given to you. Here we have A is equal to P plus PRT, and it asks you to solve for R. All right, let's solve for R. Well, what do I know? R is involved in this multiplication part here, right? P times T. And we also got this addition going on beside it. It's got plus P. So what I'm going to do is I'm going to subtract this P from both sides because it's positive. It's going to go away. Now I got A minus P is equal to PRT. What undoes multiplication? That's division. So we're going to divide by PT. And now, and I'm just going to write R first because as I read left to right, R is equal to A minus P, all divided by PT. All right.